Hello class, welcome to Geometry Lesson 8.1, which is all about right triangles and the Pythagorean Theorem. By the end of this lesson, you should be able to prove the Pythagorean Theorem using similarity and establish the relationships in special right triangles. Honestly, we're going to focus mainly on just using the Pythagorean Theorem rather than proving it, and we're also going to focus on the relationships in special right triangles because it's been a few years since you've learned what those are. So let's start with a quick refresh on Pythagorean Theorem. We've done this quite a few times at this point, so I feel as if most of you are confident with it, but a good little refresher is if you have a right triangle. Remember the key thing for Pythagorean Theorem, you have to have a right triangle. So if we already have a right triangle, then I know the two legs that form the 90-degree angle are A and B, and it doesn't matter which one's A, which one's B, the two legs. So you have A squared plus B squared equals, and then C is your hypotenuse. It's the side that does not touch the right angle. That's really the only side that you have to make sure you get in the correct spot. So the side that does not touch or make up the right angle is always your C squared, okay? Otherwise, the other two you can switch around and the order doesn't matter. So that's what you use if you already have a right triangle. Let's say I want to know if three sides will form a right triangle. So if I gave you three side lengths, the way that you would check is you'd say A squared plus B squared equals C squared. If that works out and you get like 5 equals 5, then you know that it is a right triangle. If you get 5 equals 10, that means it's not a right triangle. Excuse me. The important thing for this converse is what this is called. When you're trying to prove it's a right triangle, it's the converse, it's the opposite. C squared has to be whatever the biggest number is that you were given. Okay? Again, A and B can be switched around. The order doesn't matter. But your largest number needs to be put in the position where the C is, okay? All right, so let's just do a quick refresher on how to use the Pythagorean Theorem. So again, Pythagorean Theorem is A squared plus B squared equals C squared. I already have a right triangle. I see that from my picture. And I see that one of my legs is 12. That's one of the sides that forms the right angle. The other side is just X. Whoa. The other side is just X. And then my hypotenuse, the side that's kind of off on its own, not touching that right angle, is my C value, so 13 squared. So I have 144 plus X squared equals 169. Subtract 144 from both sides and you're left with 25. Undo a square by doing the square root. And the square root of 25 is 5. And yes, it could be plus or minus 5, except we don't like negative distances. So we just leave it as the positive 5, even though it's a square root. Why don't you go ahead and find the missing side? Good luck. All right, hopefully you were left with the square root of 51. I realize I forgot to say that I want you to leave it as a simplified radical. So if you were someone that divided it out into a decimal, you should have gotten 7.14. But a simplified radical is what I want you to keep kind of as a theme for almost this entire chapter, okay? So square root of 51 doesn't have any perfect squares in it, so that is as simplified as it can get. All right, so we just used the regular Pythagorean theorem where I gave you a right triangle and had you find a missing side. Now I'm giving you three sides and saying, does it form a right triangle? So again, the only side that matters is the C. C has to be the biggest number. So in this case, that's 15. Okay, so I'm just going to say what's 9 squared plus 12 squared, and it should equal 15 squared if it is a right triangle. So 9 squared plus 12 squared gives me 225. Does that equal 15 squared? 15 squared is 225. So I know that since these two things equal each other, this is a right triangle. So I would say yes, it forms a right triangle. Why don't you try with these three side lengths? Good luck. All right, hopefully for this one that you saw that these three sides do form a right triangle because 10 squared plus 49.5 squared equals 50.5 squared. Hopefully you made sure to set up your equation correctly where you had the biggest number set as C and therefore on its own. All right, so that's our basic right triangle theorem that we have been using for a while. Now let's talk about a specific type of right triangle. So 45, 45, 90 is a type of isosceles triangle. So remember, isosceles means that we have two sides that are congruent. So I'm going to call those sides S, mainly because the book does. I am also okay if you use X, just because it's a little easier to differentiate from numbers. So I may switch between using S or X, okay? Then if you have the two side lengths that are just S, the hypotenuse can be found by taking that short side and multiplying by the square root of 2. So that way you don't have to do the Pythagorean Theorem. This is one of those little shortcuts, and you guys love shortcuts. So here's one of them. If you have a right triangle that has two congruent legs, and it's a 45, 45, 90, then you have the hypotenuse is just the side square root of 2. Okay, so make sure you take a screenshot of this or write that down because you're going to get more formulas later for a different type of triangle, and it's easy to mix them up. Okay? So if we want to find the unknown side lengths in a right triangle, we have these 45, 45, 90s. Remember, we have the two sides, I'll call them X, and the hypotenuse is just X squared root of 2. So if we look at this first triangle, letter A, what are XZ and YZ? Well, I see XY is 7. That means XZ has to be congruent to it, right? So that's also 7. And then my hypotenuse is just the leg times the square root of 2. And I'm done. I don't want you to multiply that out and give me a decimal. I literally want you to leave it as 7 square root of 2. Then let's look at letter B. What are JK and LK? Well, I know that the hypotenuse, that did not work. The hypotenuse has to be the short side times the square root of 2. So the hypotenuse equals the short side times the square root of 2. We're multiplying both sides by a square root of 2. So that means that those would cancel, right? Anytime you multiply by the same number on either side, you can cancel them out. So here I am left with just 12. Or you could even say, well, it's 12 because that's the number that goes outside of the square root of 2, just like over here. Okay, so the two sides would be 12. Hopefully that doesn't seem too bad, but I want you to try one actually later. Let's look at the other triangle first. So Theorem 8.4 is all about a 30, 60, 90 triangle. And the formulas to remember for this are, I'm just going to, instead of using S, I'm going to call this X. So the short side of the triangle on a 30, 60, 90 is called X. And if you're ever unsure which one is the short side, it's the one opposite of our 30-degree angle. Okay, so it's the one opposite of that 30 degrees. Or if that's tough for you, it's the side touching the 60-degree angle. Okay, so the short side is X. The hypotenuse is 2 times X. And then the long leg is x times the square root of 3. One of the biggest errors I see students make is they do x times the square root of 2, but the way that I try to help them remember that it's the square root of 3 is, see how we have 3 different angle measures? Therefore, we have a square root of 3. Over here, you see how we only had 2 different angle measures, because 45 repeats. That's how we know it's a square root of 2. Okay, so 45, 45, 90 has a square root of 2. 30, 60, 90 has a square root of 3. So make sure you write that down or take a screenshot because this is super important. And let's try solving some. So if we want to find the unknown side lengths for these right triangles, I see I have a 30, 60, 90. And I'm given my short side. That means, okay, the hypotenuse, always easy to go off of the short side. You multiply by 2. 6 times 2, that gives me 12. I'm done with the hypotenuse. The long side is the short side times the square root of 3. And I'm done. Okay, so if you memorize these formulas, you see how fast these problems can go. Let's look at letter B here. So then I see that I'm given the long leg this time, and I want the short leg and the hypotenuse. So if I know that the long leg equals the short leg times the square root of 3, again, it's kind of like that last one where I see, hey, I'm multiplying by a square root of 3 on both sides. I can cancel those out. And I know that this short side has to just be 9. And if the short side's 9, the hypotenuse is 2 times the short side, or 18. Okay, and those, if you're feeling totally lost, that's okay. These can sometimes take a little while to click. And I'm more than happy to help you, okay? Let's look at an example where we're applying this, okay? Alejandro needs to make both the horizontal and vertical supports, so segments AC and segment AB, for the ramp. If one 12-foot board is one 12-foot board long enough for both supports, explain. So these two distances added together, is that less than 12, right? Because if I only have 12 feet, a 12-foot board, I can't have two sides that add up to more than 12. So let's see if that one board is long enough. So I have a 30, 60, 90, and I'm given the hypotenuse. I know the hypotenuse equals 2 times the short side. So if I divide both sides by 2, I'm left with 5 for the short side. And then I know that the long side is the short side times the square root of 3. And since I don't know exactly what that number is off the top of my head, in this word problem, I'm totally okay with you guys calculating that out. So that's about 8.66. So I want to know, is 5.5 plus 8.66, is that less than 12? No, that's going to be 13.66, which is greater than 12. So the answer would be no, the board is not long enough. All right, and then I want you, this should say question 5A, sorry. I want you to try this one, okay? So you have a 30, 60, 90, and I want you to solve for AB and BC. Good luck. All right, so you were given the long side, which is 28, and we know that the long side equals the short side times the square root of 3. So hopefully you set it up something like this, where you said 28 equals x square root of 3, and then to get x by itself, you divided both sides by the square root of 3. So then you had 28 divided by the square root of 3 equals x. And if you got that far, that's fantastic. I need to refresh your brains on how to simplify that even further, because we don't like having square roots in the denominator. So the way that you get rid of that, we learned this last year, is you multiply by whatever in the square root. on the top and bottom. So then I have a 28 square root of 3, and the square root of 3 times the square root of 3 is the square root of 9, which the square root of 9 is just 3. So this would become a 3. And that is your most simplified answer, because 28 divided by 3 isn't a nice number, so I leave it just like that. That means that over here I would have 56, because 28 times 2 over the square root of 3 equals x. Again, I want to simplify that radical, so I'd multiply by the square root of 3. So I'd have 56 square root of 3 on the top, and the square root of 3 times square root of 3 is the square root of 9. The square root of 9 is just 3. And again, 56 divided by 3 is a decimal, so I'm just going to leave it like that, and that would be my answer for AB. So this BC was my short side, and AB was my hypotenuse. All right, and then what is the value of AC and BC? Good luck. All right, hopefully for this one you realize you had the 45, 45, 90, which means the hypotenuse equals the short side times the square root of 2. So you can set it up as 14 equals x square root of 2. Divide both sides by a square root of 2. But again, I don't like having a square root in the denominator, so I multiply by square root of 2 over square root of 2. That process, just so you know, is called rationalizing the denominator. Okay, so then if you multiply by square root of 2 over square root of 2, that gets rid of that radical, the square root in the bottom, and you're left with 14 square root of 2 divided by 2. Well, 14 divided by 2 is a nice number, so I get rid of the fraction, I just write 7, because 14 divided by 2 is 7. And then I leave the square root just like that. And that is my answer. So I'd say probably the trickiest thing for you guys is going to be getting used to working with the square roots again, okay? And then here's your concept summary. The first two up top talk about Pythagorean Theorem and the converse. So if you already know it's a right triangle, use Pythagorean Theorem. If you want to know it's a right triangle, again, use Pythagorean Theorem, and if they equal each other, then it is indeed a right triangle. Then you have your 45, 45, 90 triangles and your 30, 60, 90 triangles as well. So make sure you screenshot all of those formulas, and you need to memorize them, okay? I will not give those to you on a test. So if you have any questions at all, please don't hesitate to ask, and have a wonderful day.